Are you troubled by strange ways that your organization delivers software?
Do you experience feelings of dread when preparing to work a long, painful application release?
Have you or your coworkers experienced buggy, unstable services after a deployment?
Does it take days, weeks, or even months to build and release applications in your organization?
If the answer is yes, then don't wait another minute. Fire up your browser and watch the professionals. We're ready to believe you. Howdy, I'm Ernest Muller.
And I'm James Wickett. Welcome to our course on another DevOps fundamental, continuous delivery.
James and I first met while implementing DevOps in a large enterprise. We've run the DevOps Days Austin conference together for the last 6 years and blogged together at theagileadmin.com.
I do engineering and research over at Signal Sciences, where we've built an application security defense solution for cloud-scale companies. We practice DevOps and deploy changes over 10 times a day to our production stack.
And I'm the Lean Systems Manager at Alien Vault, also a maker of computer security solutions for organizations of all sizes, where I optimize our infrastructure and software delivery pipeline.
We feel that continuous delivery is one of the fundamental practice areas of DevOps, and it's central to a new view of application stability.
In this course, we'll address both what developers and operations folks consuming and supporting builds need to know. First, we'll cover the basics you'll need to succeed at continuous integration, delivery, and deployment, including how to construct your build pipeline.
Then we'll discuss elements of the pipeline and talk you through source control, build, testing, artifact management, and deployment.
And finally, we'll explore concepts and demonstrate common tools and practices in each area. Are you ready for this?
I am. Let's get started. This course is designed to introduce you to the basic concepts of continuous integration and delivery.
To get the most out of this course, you may want to watch DevOps Foundations here in the library. In it, James and I discuss the fundamentals of DevOps and how the three major practice areas, infrastructure automation, continuous delivery, and reliability engineering, fit into it. This course drills down into continuous delivery.
You only need to be familiar with the general idea of coded applications and the process of creating them and moving them into production to be delivered as a service. Our intent is for this course to be accessible for anyone with even basic IT experience and benefit both developers and operations staff.
While we're making our source files available to you, this isn't meant to be a lab course where you follow along and perform the activities to learn a specific technology. Instead, we'll be talking about concepts and using a wide variety of tools to illustrate them.
So while you may see, for example, some Jenkins and be introduced to what it does, we won't be teaching you about Jenkins or any technology specifically. Our goal is teaching the foundations of continuous delivery and familiarizing you with the wide variety of tools you might choose to implement for your preferred approach. We want to arm you with principles, patterns, and a vocabulary to help you along the path for your DevOps transformation.
Now let's get started with DevOps Foundations, Continuous Delivery. For those who have access to the exercise files, we've included some scripts and code so that you can examine them on your own. Simply download the exercise file zip file and open it up. Inside, you'll find folders that organize the scripts by the movie numbers.
If you don't have access to the exercise files, don't worry. You can simply just follow along or type them in as you see them on the screen.
First, a couple words on following along with the demos. So with the sample files, we've provided a readme.md file that contains a lot of information on how to set up your system for each individual step. The biggest one that you'll want to do is to install Docker for Mac, Windows, or other from docker.com so that you can run the Jenkins and Nexus and test fixture containers.
For version control in action, we install Homebrew. With that, we install Go, Vim, and Git. There's also some setup for how you set up your path for working with Go.
You'll also need a GitHub account with your appropriate SSH keys installed to be able to pull the Word Cloud Generator app. For the CI in action with Jenkins video and the following videos, you'll need Docker installed as mentioned. The README contains the information seen in the video on how to start and how to stop it.
For the video on unit testing in action, many of the same requirements we set up earlier for Git are the same here. But again, you'll want to make sure you want to have Go installed, Vim, Git, and a lot of the profile settings for Go and your Go path.
For deployment in action in Chef, all of the installation has already been performed as part of the Docker containers provided, but the README contains information on how to run it by hand if you'd like to. For integration testing in action with About, this container is also built by the Docker Compose file, but if you want to build it by hand and run it with or without a hook file, the instructions are here on how to do that. For UI testing in action with Robot, as I mentioned during that course, it's possible that the virtual env provided might end up not working on your system. If that's the case, you can just blow away that venv directory inside the robot test subdirectory and execute this sequence of commands. Essentially, you're installing the virtual env Python package, you're installing a bunch of stuff in it, and then when you're done, you deactivate out of that venv. And then anytime you want to run it, you go into robot tests, you source that activate script, you run robot, and then, of course, eventually you deactivate again whenever you want to get out of it.
For doing security testing in action with Gauntlet, again, we use Homebrew, also Docker again for Mac, but we also use retire.js, and that's a Node package installed via NPM. So we have a couple other requirements here as well. Because the way Gauntlet talks to Arachne, there's a setting in our etc host file to set localhost 127.0.0.1 over to a name word cloud.
So there's a couple advanced topics in case you have problems. So the Jenkins Docker container itself runs a Docker container to run About for the integration testing. If you get an error of this form about permission denied when trying to connect to docker.sock, the solution I have in here, it works for Mac for sure. You may need to determine the actual ownership of the var run docker sock file on your system, and in the Docker file for CD Jenkins, change the line that does an ownership change specifically. On Macs, it's owned by staff. On Linux, it's often owned by Docker, and whatever you would need to do on your flavor of Windows system to make that actually work. There's also some information in here on running the containers in isolation if you want to play with them without using the Docker Compose file, and some information on if you're going to start from scratch instead of using our provided Jenkins Home and Nexus Home directories, how you can go through a little bit of that setup on your own. And then finally, the test fixture. I had mentioned that I had set up some of the chef cookbook skeletons and whatnot. I didn't want that to be totally magic, so that is also here in the README, and you can start, with an empty directory and set all this up on your own for an additional learning festive experience.
All right. Well, we hope you enjoy the course, and thanks for tuning in.
You may have heard the terms continuous integration, delivery, and deployment thrown around already. So first, let's talk about exactly what each term means.
Yeah, let's start with continuous integration. It's the practice of automatically building and unit testing an entire application frequently, ideally on every source code check-in, dozens of times a day if necessary.
And in CI, those check-ins are frequent. You don't use long-running parallel code branches that'll cause a large, messy merge effort the older they get. Or if you do, you at least set up builds for them in the meantime to continually validate that they work.
Right. Yeah, ideally, developers will build and test their application on their local desktop even before submitting to a shared build system. It's all about shortening the feedback loop for every change.
Continuous delivery is the additional practice of deploying every change to a production-like environment and performing automated integration and acceptance testing after it passes its build and unit tests.
This can involve small-scale deployment on a single server using mock environments created with Docker containers or virtual machines to mimic a production environment so that you can run those integration tests. Testing should generally end up with a deployment to a production-like environment.
This allows us to validate the deployment process and to see what functionality and performance look like in a real deployment environment.
Right. Continuous deployment extends this concept to where every change goes through full automated testing and is deployed automatically to the production environment.
Sounds scary, right?
I mean, it can feel terrifying.
But large-scale web properties like Facebook, Etsy, and Wealthfront use continuous deployment as a key component behind their success. Even at my work, we use continuous deployment for the microservices that back up our Open Thread Exchange website.
Now, once you're making one change at a time and you have trustworthy tests that can find issues in your application, then you can remove all the manual gates that get in the way of a continuous flow to production.
Of course, there are build and release processes that aren't anything like this. Giant releases of hundreds of changes piled up for months, products that won't even build without days spent cobbling together merge conflicts and manual workarounds.
I've been there. You don't have to go all the way to continuous deployment. It's not right for every product, and none of this is really a mandatory part of a DevOps implementation. The first true DevOps team that Ernest and I worked on, we didn't go all the way to continuous delivery. However, a bunch of teams that we've worked on since have seen huge benefits of using continuous delivery.
In most situations, CI and CD is a huge improvement for products and teams of any sort. In our next video, we'll go into the benefits of continuous delivery in depth.
Doing continuous integration and continuous delivery, it takes some time and investment.
Investment's the right word for it. It's important to realize that the time spent setting up your pipeline is worth it. Your CD pipeline will pay out benefits well into the future.
For each organization and implementation, you'll find different benefits and probably several more than we give here. However, we see 5 near universal benefits of implementing continuous delivery. These apply no matter what language, platform, or system that you're running.
For the first benefit, we're borrowing the phrase empowering teams from the continuous delivery book. By nature, our pipeline is a self-service system that makes the process of software delivery transparent and understandable to the entire team.
Now, this is really a cultural change for many organizations. Once the system is operational and trusted by the team, it changes how collaboration happens. It makes the team less reactive, and it reduces the strain between developers and operations, the QA folks, and security.
It's hard to quantify this with a number, but if you ask anyone who does CD right, they'll report that their team culture changes significantly.
Yeah. Our second benefit is that the total cycle time is decreased dramatically. This is the time from code commit to running in production.
Using older methods, this time was generally measured in weeks or months. Now it's measured in hours or even minutes.
The 2017 State of DevOps report found that low-performing organizations needed times ranging from 1 week to 1 month to make a change. However, organizations that use continuous delivery, they can reduce their cycle times to that hour and minute range we were talking about earlier.
Talk about being able to deliver market value quickly.
Yeah, talk about synergy.
Shut up, man.
All right, a third benefit is security. It might seem odd that security gets better if you're moving faster. It's tempting to think that it's important to go slower to do security.
Right, it's actually the inverse. This research shows that high performers who continuously integrate security into their work spend 50% less time remediating security issues than low performers.
Yeah, 50%, that's a huge gain.
And I can tell you from experience, it makes it a lot easier to go through compliance audits. It happens the same time, every time, is all they want to hear.
We're going to cover security testing more later in the course, but let's move on to the next benefit.
When not using continuous delivery, we used to have big meetings where we'd gather all the stakeholders. And at those meetings, we'd craft a plan to take the code and deploy it to production. There were always steps that were untested, and often we couldn't even practice them very well due to how the systems in production varied.
Yeah, I remember those days. But in continuous delivery, you're always practicing. Each code commit results in a build of a release candidate that, as long as it's functioning as expected, it gets released.
The rhythm of continuous delivery removes stress from teams both in development and operations. No longer a release date's a stressful event.
That's right. The big release has now turned into just a regular Tuesday morning or a Thursday afternoon.
The fifth and final benefit is to deliver more value, period.
Yeah, this goes hand in hand with the ability to deliver value faster, as we discussed earlier. Organizations and teams doing continuous delivery find that they spend less time doing unplanned work or rework and more time adding new features. Due to continuous delivery practices, there's a 29% growth in feature development that was previously spent on remediation.
That makes sense, right? Less time reworking code due to integration issues translates into more developer time available to write new features, which adds more value. What manager wouldn't love to have more work done without having to add more people to the team?
Well, this sums up most of the major benefits of continuous delivery. Of course, for your team and organizations, you might see others. However, from our experience, we see these as almost universal and very compelling.
Now that we have you all convinced of the great benefits of continuous delivery, join us in the next video where we discuss continuous delivery in practice. A build pipeline is your sequence of operations and the tools that perform them between your source code and your deployed system. How you compose your build pipeline and the flow between its elements is much more critical than which exact tool you use in any particular area. Tool-wise, you start with the source code repository, like Git, Perforce, or Subversion. This is where you keep all your source code. And I mean all of it. App code, deploy scripts, infrastructure definitions, everything. Its job is to keep your code safe, version it, and provide facilities around handling multiple people committing code to the same items. Then you have a build system, which watches your repository and triggers whatever build is required when it changes. Jenkins, Bamboo, and TeamCity are popular build systems. There's also online services like CircleCI and Travis CI. Even build scripts you cobbled together that run make can qualify, but these lack the webhooks, auth, plugins, and other features that'll help you optimize the process. Its job is to build code and run unit tests, and of course to provide feedback and visibility into the build process. Depending on what language you're using, you may have a variety of compilation and build orchestration tools. If it's a compiled language, you may need a C or Go compiler. Interpreted languages may not have a compilation step and skip straight to packaging. You might have a build definition file, like a make file or a Docker file, or perhaps you use something like Maven, Ant, or Gradle as a command line build orchestration tool. This allows developers to build on their local machine and to keep as much code and source control and out of the build console configuration as possible. You probably have a unit test harness, which may be a separate tool, but is invoked inside the build system. Unit tests are basic tests designed to verify a piece of code is doing the job it was intended to do. Unit tests don't have dependencies on external systems. At most, they mock or stub out anything outside their own code base. They're your first line of defense in figuring out whether your build is going to work as expected. The next step is packaging what you've built into an artifact. Part of this is usually language dependent. For example, Java code is usually put into jar files, and then those are combined up into a war or ear file. But you may have a higher level packaging structure you prefer, like an RPM package or Docker image. Once you've packaged the code, it goes into your artifact repository. Some people just use a storage device or Amazon S3 for their artifacts. Others use tools built for the job like Nexus or Artifactory. Or there's technology-specific repos like Docker registries or Puppet forges. In the old days, a build engineer thought they were done here. But not so. You have some bits on a drive somewhere, not a service delivering value to customers, so your job isn't done. You need a deployment tool to bring up a working instance of your service. You'll use the same tool to deploy both to your test and production environments. Your deployment code is code, and like any other code, you want to find any issues in the build and test cycle, not when you're deploying to production. So you run your deployment tool on a test environment, sometimes also called a CI environment, to get your service up and running. Next, you perform integration testing, which is designed to exercise a real running service in a real environment and ensure that it's working correctly. Then you have an end-to-end acceptance testing stage. This may include a manual testing component. Manual tests can be mostly dispensed with once you reach CD process maturity, but will almost always predominate initially. Then you use the same artifact that passed testing and the same deployment tool to deploy it to the production environment. Ideally, you use some of the exact same acceptance tests to test it there as well. There are many more types of tools you can layer onto your pipeline. Test coverage measurement tools, linters, security testing tools, performance testing tools, but these are the basics. And nailing the basics is the key to getting to continuous integration, and then, if you want, to continuous deployment. In our next chapter, we're going to create a sample build pipeline and walk you through each part of it, explaining the decisions you need to make and the best practices to foster continuous delivery.
All right, now that we've covered the basics, let's see how this might work in the real world.
Over the rest of this chapter, we're going to build out a sample continuous delivery pipeline for a web application. This pipeline will walk you through the core components you'll likely need to implement.
Wait. Before we get started, we should really add a quick note of caution here. No one's pipeline looks the same.
That's right. This is just a sample pipeline. We built it with open source technology to help deliver a sample web application written in Go.
Yeah, now you may be using Java, Ruby, or Node.js for your application.
You may be using a mix of open source and commercial software.
Yeah, you may be not delivering web software at all. You might be delivering software in the form of a device driver or mobile games.
But you can benefit from CI and CD no matter what you're building or what the unique details of your environment are.
But each product and team, they're going to have their own unique challenges for requirements.
We plan to arm you with the core principles to determine what you need to do to build a pipeline from scratch or to modify your existing pipeline to increase flow through your build system.
Now, for this course, we're starting off covering version control and core practices for development teams when working in a continuous delivery environment. For our pipeline, we're going to be using the popular version control system Git, delivered through GitHub.
Then we move into build systems and cover practices that are important for CI. We'll put it all into practice using the open source build system Jenkins.
Next, we'll move right into handling artifacts using Nexus for an artifact repository.
We'll hit testing in 4 main areas: unit, integration, UI, and security testing. We try to stay away from specific Go testing details and concentrate on how to test your application from the inside, from the outside, and as a malicious user.
Now, once we're sure our application is tested and ready to go, we'll deploy it via Chef.
Of course, the path through a build system isn't always linear. Each stage is a feedback loop that lets you incrementally improve each change before it gets released. Along the way, we introduce each area with its goal, along with principles and practices we found to be important and work best in that phase.
Yeah, and at the end of this course, you should gain a working knowledge of a pipeline and how you can use this as a roadmap for implementing your own continuous delivery pipeline.
At the end of the course, we'll cover some tips and real-world advice for doing continuous delivery in large enterprises and less than perfect organizations.
Yeah, and that's the really fun part. That's where the rubber meets the road.
For sure. So next up, we'll talk about version control. One of the key differences between operations staff and developers has been their use of version control. For years, developers have used version control, but for operations organizations, it simply wasn't common practice.
Yeah, well, nowadays it's a must. So let's see how version control fits into the flow of our pipeline.
Version control, also referred to as source control or revision control, contains all the source code for your project and maintains the current and historical state of that code.
Yeah, the goal is to use version control for operations, development, QA, security, and every other team needed to deliver the software.
Let's dig into some best practices that we recommend for version control.
All right, the first rule of version control is you always use version control.
This means no project is too small not to use it. Even build scripts or cron jobs, everything gets put into source control.
All right, this brings us to the second rule of version control. You always use version control.
In the first chapter of the Continuous Delivery book, one of the definitive resources on the topic, the authors remind us that it should be possible for a new team member to sit down at a brand new workstation, check out the project's revision control repository, and run a single command to build and deploy that application to any accessible environment, including their development workstation.
Yeah, with that goal in mind, everything really means everything, from install and setup scripts to runtime provisioning and deployment.
This leads to another important practice: commit often.
Now, it's tempting to check in code in large batches, but it's better practice to commit smaller pieces of code. Even uncompleted features can be committed if hidden behind a feature flag.
This allows anyone seeing the commits to be able to understand what's happening in the codebase. Collaboration is one of the main goals behind version control.
This is why our next practice is to use easy-to-understand commit messages. These messages live alongside the code and give insight into what changes were made in a commit.
Do your team and your future self a
Yeah.
favor by using descriptive messages. This is why we recommend committing often, as it's easier to craft a more meaningful commit message for smaller changes than a big batch of dozens of changes.
Okay, that said, our next practice is don't commit code that you know fails tests or won't build.
That's right, leaving any part of the continuous delivery pipeline in a non-functioning state should be considered a bad practice in your team.
All right, let's move on to a more controversial topic, branches. Now, I was once on a team that wanted to use branches, but our CTO asked someone to Google Git branching strategies. Okay, some 85,000 results showed up, and he used this to say that branching is confusing. No one does it the same, and it inhibits the team from understanding the current state of the system. So instead, we ended up sticking with a trunk-based approach, also called a master branch approach.
I use a master branch approach too. The 2017 State of DevOps report found that high performers have the shortest integration times and branch lifetimes, with branch life and integration typically lasting only hours. Low performers, on the other hand, had branches lasting for days, weeks, or even months.
Yeah, they found that developing off of trunk or master was highly correlated to high-performing teams. Unlike the workflow that proposes a lot of branching and forking or pull requests where you send a change for review before it gets merged into the main branch.
It's not that you shouldn't use branches at all or not use pull requests. It's that the mechanisms to handle changes should be small and easy to understand. In my shop, we use very short-lived branches, one ticket's worth, and issue a pull request to get them merged into master.
Yeah, to make bigger changes, yet in small bites, you branch in the code. The pattern you can use is called branch by abstraction. This is where you use feature flags in the code to control cutting over to new areas of code.
In this way, all the new and old code gets more eyes on it, goes through more builds, and allows you to incrementally make a large change in your code base.
Now, one of the really cool things you can do is set up hooks to do things like run tests in development before committing into version control. Git allows you to do this, and I'll show you how to do it a little bit later.
It's a good practice to put fast local tests like linters and formatters into a pre-commit hook to make sure they're always run before the commit step.
Yeah, all tests should be run locally, but forcing some amount of pre-commit testing helps you keep the team from committing easy-to-catch mistakes and breaking the build.
In my shop, we have pre-commit hooks that do things like ensure you have a ticket number in your commit message before you check in and run unit tests. The test results even get put into the pull request.
All right, the last practice is to be careful with secrets. Source control history is able to be searched by everyone on the team and, depending on your project, any customer or maybe even person on the internet.
It's good practice to not submit access or secret keys, passwords, or crypto certs into source control. Make sure you have tests in place to detect any attempts to submit these and alert your team if they do make it into your revision control system.
All right, coming up, we're going to put all these principles into practice using GitHub. We spent some time talking about version control, so let's see it in action with the popular version control system Git, using GitHub for our server. For most of the demos in this course, I'll be working on a terminal on a Mac. If you're on Windows, you can follow along on Bash on Ubuntu on Windows. If you need more information on installing and using it, check out this website. There's also WinBash if you prefer. Before we get started, you'll need a GitHub account and SSH keys, which is easy to get at github.com. All right, back over here at the command line, let's clone our repo. I'm going to type git clone git at github.com:wicket/word cloud generator. This brings down the entire repo on my local disk. This not only gives us the code at the current state, but all the history up to this point. Okay, great, the clone worked. Now I'm changing directories into the repo I just cloned. Now that I'm in the repo, I can see the history of the repo by typing git log, which shows us all the commits that have ever happened in the repo. This is central to version control because it allows us to go back in time. Let's take a look at the details of one of these. I'm copying one of the commit IDs. I'll type git show and the commit ID I just copied. This shows the description message of the commit and what changes were made. All right, great. I can see everything about past commits, but let me clear my screen and let's see if we can move on to making a change for the future. I'll just change the project description in the README. I'll open Vim to edit the README file and type a new description. You might have noticed that Vim adds notations to let me know what I've changed but haven't yet checked in. Most IDEs have GitHub integrations like this. Okay, let me type this in and our change is ready. Okay, let me save that and let's get out of that. I can check what Git knows about my change by typing git status. If I changed multiple files, all would have shown up here. There isn't much detail here other than what file changed. I can type git diff to see exactly what changed. Even with simple changes, I'm in the habit of checking my work by making sure that what I think I changed is what I actually changed. Git diff has saved me more than once from checking in the wrong code. Okay, looks good. Let me clear my screen here. Before I add and commit this change, I want to set up some Git pre-commit hooks, which tell Git to take certain actions before proceeding. Hooks are optional and are set up by individual developers, but that means that you can't trust that everyone on the team runs them, and they aren't a valid security or testing control. You'll need to establish team standards and practices to get the most out of hooks. One good practice that I often see is where teams add their Git hooks into the repo and then include an install script that everyone runs, and that's what we've done here. Let's look at our hook by typing cat.hooks/git precommit.hook. This script runs before a commit is allowed, and it runs unit test and then Go specific formatters and linters. Any issues found will stop Git from committing. To make it easy to set up, I've added a helper in our makefile. Let me clear my screen and then I'll open up the makefile. So I've scrolled to the bottom of the file. There's a command called git hooks. This copies the pre-commit hook over to the location where Git needs it to be. Okay, let me exit out of this and let's go ahead and run make git hooks right now. Okay, we should be good to go. All right, now let's add our change and commit it. We can add our change by typing git add space dot. This picks up all our changes in the repo, and then we're going to type git space commit -m and our message, adding more text to our README here. Now when I save this, my pre-commit hook is run, tests are pass, and my commit is ready to go. However, nothing has actually been changed on our Git server. When I type git status, I can see that my local branch is ahead of origin master. If I had more commits to make before submitting to the server, I could do that, but we're all set to push, so I'll type git push, and my change is visible to everyone with access to the repo. All right, now let's leave the command line and head over to the repo in the browser. I'm over at github.com/wicket/wordcloudgenerator. I'll click on commits and you can see the list of commits with messages for each change. The one at the top is the one I just sent in, and when I choose it, GitHub shows me what changed between commits. What's neat about GitHub is that it's a bit of social media meets coding. I can comment on commits and have discussions around the code. This commit has already been put into master, so the conversation is happening a bit after the fact, but I could have made a pull request and then chatted with others about it. GitHub provides a wiki and a way to handle issues. Issues are an easy way to track bugs, code changes, and new feature development. I think we can close one of our issues for this repo. Let's add a note on the commit, which we could have also done in the commit message, but we can reference the issue number. Now, let's head over to the issue and check it out. I'll click Issues in the nav and then Issue number 1. Here we can continue the discussion or see the code that was automatically linked from our comment earlier, or we can close the issue. There are a ton more features in Git and GitHub, but let's hit one more central topic to continuous delivery, webhooks. I'll click on Settings and Webhooks, and you can see that I have a few set up already, one for our ChatOps tool HipChat and one for our CI system. Later we'll use Jenkins, but here I've wired in CircleCI, which is a SaaS-based CI system. What's great about this is that every commit, branch, and pull request gets tested by CI, and the status gets integrated into GitHub. Let's go back to the code and commits. There's a green check mark showing the build status for every commit, which I can select to see the status. This maps code commits to build and makes it really easy to see what code changes broke the build. Of course, with our chat system, we get notifications when the build runs and succeeds or fails. This brings together the team to create the culture needed to do continuous delivery. If you're using an IDE to code, it'll perform most of these steps for you, but this is the UI for what it's doing under the covers. Next up, we'll dig into the continuous integration build systems itself. Let's talk about continuous integration systems and take a quick tour of options for CI. Now, there are three main categories we want to look at. Let's start with open source. There are others like GoCD, but the de facto standard of open source for CI is Jenkins. You download the software, host it yourself, either on-prem or in the cloud. Now, because Jenkins is so popular, in the next video, we're going to be looking further into Jenkins to build out our web application. The second option is to use one of several commercial vendors that provide hosted CI systems or ones that run in your own infrastructure. The third option is using a SaaS for CI. These popular offerings are a pay-per-use or pay-per-month CI solution. Many of the popular ones like Circle CI or Travis CI offer a free tier for public projects in GitHub or a single private repo. Which system you implement will depend on your project, budget, and your organizational appetite for risk. For anyone just getting started, I generally recommend going with the SaaS-based offering. You can quickly start using CI without having to worry about setting up any infrastructure. However, if you're in a large organization, the which system should I use, that decision may have already been made for you. Don't worry. Remember, CI is a practice, not a tool. No matter what system you're using, it's about implementation. Now, there are several important principles and practices to consider when using a CI system. First, start with a clean environment. Each build should be a blank slate. CI systems generally put protections in place using the idea of workspaces or containers to maintain the segregation between builds. It may seem like a good idea to maintain the state of a previous run on disk or write to a system environment variable, but you're going to want to resist this. Every time I've seen this, it's eventually caused problems. Another practice I recommend is build to pass the coffee test. From code commit to receiving results, the amount of time should be equivalent to the time it takes for a person to get a cup of coffee and come back to their desk. This is why I always recommend you shoot for 5 minutes or less. This is going to take a commitment from the team to spend time refining the tests and the builds whenever they get slower over time. Speaking of teams, I found that there are a few good guidelines most teams need to agree on when using continuous integration. You may have additional needs in your team, but these should start a good groundwork for you. Before committing code, make sure you run all the tests locally. It shouldn't be a surprise that your build passed when you committed some code. The CI system isn't a replacement for doing local testing on your development machine. Next, don't compound problems by committing code to an already broken build unless you're fixing the problem. Another team commitment is never leave the build broken. This always applies, but is even more important for distributed teams. If you break the build, you fix it. No lobbing code into the system before leaving for the weekend without making sure the build passes and you deploy it to production. The corollary to this is don't remove failing tests. Now, this should go without saying, but I've seen it numerous times, and where a build is broken, instead of fixing the problem, a test gets muted. That's never okay. If a test is no longer valid, then it should be removed based on product functionality changes, not due to its failing or passing status. Let's take a moment to talk about notifications. Now, when setting up CI, we like to put messages about the build in our chat tools and our monitoring systems. At work, a notification in our chat tool Slack is generated for code commit, build start, build completion, deploy to stage, and deploy to prod. If code goes undeployed for more than an hour, a notification is sent for that as well. For most of these events, we also emit an event in our monitoring tool Datadog. This way we can correlate errors to code changes. Most of the CI systems integrate with major ChatOps platforms and monitoring tools, but if there is any reason to switch to a different tool, this might be the one. All right, coming up, we're going to take a look at the popular CI system Jenkins.
Now let's take a look at what a CI system looks like in practice. For that, we're going to use Jenkins. Jenkins is a free open source tool. Like most free open source tools, it's a little rough around the edges, but it has a lot of community support. Also, it's written in Java, so it runs on any platform from Linux to Windows to Mac. For ease of use, I'm going to use the Jenkins Docker container. If you've installed Docker for Mac, Docker for Windows, or whatever suits your platform from docker.com, you can use our example files to get started without even needing to install software. I'll run through it, but this information is also in the README and the exercise files. I'll be doing this at the Mac command line, but it should work identically on Linux or the Bash in the Windows 10 anniversary update. And honestly, it's only a little different on the Windows command line. The Docker commands will be the same except for paths. So first, we will go look at our Docker file in our continuous delivery class directory. We have our README that contains all the information that you need about how to set up and get going for each of our videos. In this case, we're going to go look at our CD Jenkins directory and view our Docker file. I've made a slightly customized version of the Jenkins container. The standard Jenkins container comes stripped down without even basic stuff like make installed. So in this Docker file, I'm taking the stock Jenkins container from Docker Hub, installing build essentials and some other basic packages, and turning that into a container called cd_Jenkins to use here. I'm going to build and run that container using a Docker Compose file that I have at the top level. So what this is going to do is it's going to build that container that I have down in cd Jenkins, create an image called cd Jenkins:latest. It's going to expose ports 8080 and 5000, which are the ports that the Jenkins application uses. And it's going to mount as a volume a pre-installed Jenkins home directory, which we've provided in the example files, that's already set up and has a build for our word cloud generator application included. So we will run Docker Compose up -d for detached and -- build to build any of the containers that haven't been built. In the interests of speed, I've pre-built some of the containers, but here you can see our Jenkins container being built, installing build essential. You can expect this to take a little while because it's actually installing compilers like GCC as part of its work. For the purposes of our demo, we're going to speed this up a little bit for you. All right, now that it's done, we can look and check that it is all running. And sure enough, we have a number of containers, and our Jenkins container is running with ports 5000 and 8080 exposed. Okay, here we are back at our browser, and we can go to localhost port 8080 and wait a little for it to start. It's Java, so it's a little slower than average. Shots fired. And voila. You can log in using our pre-configured credentials, admin and the Agile admin. That's also with the README. You don't have to remember that. Now you can see that we already have a build in here for Word Cloud Generator, our sample Go app that James has shown you. We're going to go in and configure its build using the Configure widget. As you can see, we've set it up to look at our Git repository as the source for the application. We have also set it to pull the source code repository every 15 minutes. If you've installed your build pipeline on some constantly running hardware, you could set up webhooks to execute a build every time there's a check-in. For our purposes, we've simply set it up on a timer. If you need any information about any of these options, right here in context, you can hit the little question mark and get some in-context help that explains how to do it. In this case, if you're not familiar with cron-style scheduling notation, this explains it to you. So you can see here we've chosen to use Go version 1.8.3 to build the Go app. And then here is the meat of the build, the actual build steps. This is a script that I've written to run the build. My script prints out the make file just as a debugging step so you can see what it is you're actually doing. It sets up the Go dependencies, and it runs make to make the application, and it zips it up. I have other later steps to upload to Nexus and run tests. I'll go over those in later videos, but I wanted to show you how you can come in and add additional build steps of various types. And then here, once the build is over, you can add post-build steps like publishing test reports or doing email notifications. Now, to make all this work, we had to add a couple plugins. Jenkins works fundamentally on the concept of plugins. It doesn't do a lot in and of itself. You saw I had to even install make. So what we'll do is go into Manage Jenkins and go into Manage Plugins so you can see how this works. In fact, it's warning me that 6 of my plugins are out of date and need updates. So some of these plugins come by default. But as you can see, I've installed the Go plugin to specifically support Go builds. I've also added the Nexus Artifact Uploader plugin to upload into Nexus. Now, some of these plugins require configuration. Again, under Manage Jenkins, under Global Tool Configuration is a popular place for plugins to have you configure them, including versions. So you can see here that a section for Go has appeared. That appeared when I added the plugin. And then I can specify several Go installations. I've set up one for Go 1.8.3, but if you wanted to conduct builds of different components using different versions of Go, you can easily just add separate installations here, and then the build stage specifies which of those installations it needs to use. So if you don't do this and you just install Go, for example, as part of that Docker file or on the system that Jenkins is running on, you're constrained to building apps with only that one version. Or if you're trying to override that version for a specific build, you run the risk of getting the wrong version. So I prefer my build system to be able to build different technologies of different versions using the configuration the way Jenkins intends it. There is a Jenkins plugin index on jenkins.io that exposes loads of plugins for many different technologies. You can also write your own pretty easily. So let's run our build. Back to Jenkins, we'll go into our word cloud generator build and just click Build Now. It'll say Build Scheduled, and then down under here, you'll see a little blinking light appear, which indicates that it's dispatched a build. Here you can see my build history, and I have 3 previously failed builds and 2 previously succeeded builds. Blue indicates success in this case. So the build can take up to a minute. We're going to speed this up for you as well. And it worked. You can see here we have a successful build because it's blue. So let's go click into the build and look at it a little bit more. It would tell you here any changes in the actual source code it checked out. In this case, we didn't make a change to the app between builds, so it says no changes. And you can go into the console output to see all exactly what it did. And sure enough, here you can see it checking out the code from GitHub. You can see it printing out the makefile. I always find that useful so that you can see exactly what it is it's doing. You can see it set up its Go dependencies, and then it runs make and makes the actual executables. The unit tests run, of course, first, and then later on the steps that you haven't been exposed to yet run integration tests and deploy it to the artifact repository. From here, you can add more and more complexity as you need it. Add a plugin to notify your Slack or HipChat about build breaks, and you can use their pipelines feature that lets you define your builds as code instead of clicking around in a UI. I've been using the UI for purposes of this demo, but it leaves me feeling dirty. Ideally, we'd have a build for our Jenkins container itself in Jenkins, and all of our builds would be defined as code checked into source control instead of being configuration inside a tool. As you may have noticed, Jenkins isn't all that magical. It's providing a basic framework to poll and then to run build scripts. The technology isn't the key here, it's the process you implement with it. Build and test in as small batches as possible, and get feedback on issues back to the devs as quickly as possible so they can fix it while it's still fast and easy. And automate as much of the flow as possible because automation is fast and testable. Next up, we'll talk about packaging and artifact repositories. Now that we've seen our CI system in action, let's talk about packaging and artifact management. If you make packaged software or use a compiled language, then you just assume you're building artifacts. But if you're one of those kids nowadays with a Python or PHP-based website, you might wonder what's wrong with just Git pulling your code to your production server. Building and distributing your code as packaged artifacts provides reliability, composability, security, and shareability. Probably the most important reason to generate artifacts is to ensure what you've tested is exactly what's going to production. As much of the preparation work as you can do in a controlled environment, compilation, pre-processing, packaging, the less there is to go wrong in each subsequent stage in the CD pipeline and in each deployment. If you build your application with specific language versions, specific library versions, specific compilers or interpreters, then your testing's invalidated if you change any of those things. A common anti-pattern I see is to build and test, and then build in some different mode for production, and assume that the testing you performed on that previous build is still valid. It's not. Build it, test it, and package it, and package any other dependencies like interpreter versions along with it, and deploy that. Also, most apps nowadays are composed of more than one piece. Packaging can provide dependency management between your code and its dependencies, and between it and other pieces of software. This is a good reason to use a common packaging format that supports dependency definition, like DEBs or RPMs. In many cases, you don't just have one kind of technology, so consider wrapping up different technologies in a common packaging format. For example, at work, we package our Java jars, Puppet code, rules files, infrastructure definitions, etc., all into Debian packages, so that we can manage them in the same way and define version dependencies among both them and the third-party packages we consume as part of our built systems. In some cases, we publish internally to a native format, like a Python package repo or NPM repo for Node apps, as that's easier for other developers to natively reuse in their code, but we do a final packaging to DEBs before deployment to a server. You can also have multiple layers of artifacting. We produce jars that we bundle into DEBs, and then we use HashiCorp's Packer to create VMware images from the DEBs. And the VMware images are the artifact that we actually ship to customers. We use Maven and its JDEB plugin, which basically lets you just say, hey, turn those files and directories into a Debian package. But there's another great tool called FPM that lets you package up arbitrary files into DEBs, RPMs, and many other package formats from any system. Also, you really don't want to expose everything in your source code repos to your production servers for security reasons. When you package up an artifact, you have fine-grained control of what's going into the package and what's not. It's also good to control how code can get pushed to production by gating who can write to the artifact repository. A best practice is to only let production deployments come from the artifact repository and only allow your CI system to write to the artifact repository. This way you can maintain a high level of compliance, because there's not a way for someone to sneak code into production without it going through the controlled CI process. You can also curate external packages with your artifact repo, so that when they disappear or change, you have a reproducible build. And you don't have deployments fail because cosmic rays are making one of the many public internet software repos have a bad day. By clearly curating the packages that go into your build, you have a secure and auditable supply chain. It's very important for you to know exactly what went into your build and that you can reproduce it exactly. A build that's run with no code changes should never produce a different result. And finally, an artifact repository provides a central place for multiple teams to look at and consume components provided by other teams. By publishing to the artifact repo, you can say, this is ready to use, and with these versions. Nobody likes just being pointed at your source code repo and having to figure out how to install it themselves. Artifact packaging provides a well-understood construct for consuming your code. So before you get started, put some thought into how you want to manage your artifacts. What formats do you want to package to, both intermediate and final for deployment? How do you want to manage dependencies? And what do you want to use for the actual repository? Luckily, setting up an artifact repository is super easy, and there's free open source ones we can use to get started. In our next video, we'll use a Nexus artifact repository to publish our sample application out of Jenkins. If you're not experienced with builds, you may be wondering, but what exactly is an artifact repository and how do you use it? In this video, I'll demonstrate a common open source artifact repository called Nexus 3. It has a commercial pro version, but we'll just be using the free version in this course. There are other options that support a variety of formats. Artifactory is a commercial product available in both on-premise and hosted versions. Apache Archiva is another open source alternative. Of course, if you just need one artifact format supported, setting up your own or using someone else's Debian repo, Docker registry, etc. is always an option. I like being able to store a variety of artifacts in one place, though. Let's start our build system up by again running its Docker Compose file. Docker Compose up -d --build in case anything needs a rebuild. The Nexus server starts on port 8081. So in our browser, we can just go to localhost 8081 and it shows us Nexus. We'll go ahead and sign in using admin and admin123, which is their default password. You should probably change it if you're going to use this yourself. Now you can view by assets or components. A component is an installable unit which can consist of one or more assets, files in other words. As you can see here, we have an asset group for our class called CD class and a component called word cloud generator. If we look in there, we can see our compiled application file and the MD5 and SHA-1 hashes used to validate the file's integrity. So previously I came in and created those here in the Nexus settings under repositories. I created them as type raw because our app doesn't fit one of the other pre-existing specialized types that Nexus supports, like Maven or NuGet. As you can see, there's a lot of setup you can do in a real installation, from user authentication to operational hardening. So it's pretty simple at its core. It's a browsable library of both your artifacts and third-party artifacts you want to store yourself. So let's go look at how we integrate Jenkins with it. As last time, Jenkins is running on port 8080. We will log back in again with admin, the Agile admin. In the Jenkins video, I showed you that I had installed the Nexus Artifact Uploader plugin here. Now in our build, it appears as an option when we create a build step. So we go back into our build, we configure it, we go down and under Add Build Step, you can see that Nexus Artifact Uploader is one of the options. So here you can see where we configure the Nexus details in a build step. You can safely ignore these 404 HTTP errors. That's a known problem with the Nexus Artifact Uploader plugin. I've configured it with our Nexus 3 containers information, the group and repository, and specified what exactly the artifact is that we're deploying, in this case, a gzip file. It's taking the build artifact compiled from our Golang code and uploading it to Nexus with our app name and version appended to it. Pro tip, for decades, people have been worried about version numbers. Should this be version 3.3? In continuous deployment, version numbers are for marketing releases. It's clear and easy for internal use to just use the build number, which increments with every build. In Jenkins, you can use this build number environment variable for just that. Now you're not ever wondering where a specific artifact came from. It came from the identically numbered build. So if you're looking at the gzip file 1.4, you can go look at build number 4 and see exactly what happened there. And that can help you debug, because assuming any two builds are the same just because the code is the same and there wasn't a check-in is a rookie mistake. Now I do prepend the build number with a 1 dot here, mainly so that if I have to change build systems and start over with a lower build number, I have something else to increment. So if one day I tore down this entire build and started building this app out of another build, then I would call it 2.build number. But that can be completely separate from whatever versioning it is that people are advertising to customers. You probably also want to tag the code that you use to create that artifact with that version number in your source repo. This kind of traceability is the key to an effective build pipeline. So we could have a stage here that git tags the checked out code with the one.build number and commits it back into the repository. So let's watch this work. We will run a new build. It'll be build number 7. We'll speed it up because it'll take a minute. All right, our build's complete. Build number 7. We'll go back over to Nexus. And sure enough, a new artifact, version 1.7, has appeared here in Nexus. So now we want to use that artifact. Well, it's available via the Nexus API, so we can just grab it by curl or wget or whatever. So what I'm going to do is I'm going to SSH into our test fixture container, which has SSH running on port 2222. Password is the Agile admin. All right, and nothing up my sleeve. We're going to pull it down just using curl. We're going to use the admin credentials for Nexus so that we get authed. And then for the URL, it's going to be our Nexus container running on port 8081, and then the URL to its API, which is kind of long. Put our version number in there. And we will output it locally here as the same file name. All right, and there we have it. In fact, here's a neat trick. If you find a file on your file system and maybe it's been renamed, you're not sure exactly what it is, you can get its checksum and go search in Nexus by that checksum. So I'll run MD5 sum on word cloud generator. And then back in Nexus, you can go search on that checksum and it finds the right file for you. So if you ever get confused and need to trace back from a file on your file system, that's a handy little trick to use. All right, we're back in our shell and we want to run our little word cloud generator. So the first thing we're going to do is we're going to unzip it. The second thing we're going to do is, because earlier in the class we ran a build, it actually went ahead and deployed and ran a word cloud generator on our text fixture. So we're going to do a PS and then we're going to kill whatever process ID that it's already running as. In my case, 268, but it'll be different each time. And then we just will probably need to chmod word cloud generator to be executable. And then just run it in the background. It'll run, should bind to port 8888, and then we'll go over to our browser to take a look. All right, and here we are back in our browser. We'll go to localhost 8888. And sure enough, here is our word cloud generator app. We will give it just a little bit of text. A quick brown fox jumping over a lazy dog will do it. And sure enough, we get a word cloud with a big "the" running that 1.7 version of that artifact. If it doesn't work, we know what build to go dig into and what code that build pulled. Also, we could set up limited permissions so that there's read-only users that can only pull specific artifacts to deploy them. We can always go back and check out an older artifact and redeploy it if there's a problem without having to rebuild. So that's the artifact repository. It's deceptively simple. And while the integrated functionality some of these tools provide is cool, like scanning your code for components bearing software licenses you shouldn't be using, some people with simple needs will just use S3 buckets or a file server to hold them. It's the semantics that you put around your artifacts and their flow through your software supply chain that's the important part. Next up, we'll get into testing.
Do you want to know the trick to continuous integration and continuous delivery?
I do.
It's all about the testing.
To perform continuous integration, you need to be performing continuous testing, and that means automated tests that you trust.
What do we want out of our tests? Well, to find bugs, right? Well, it's a little bit more subtle than that. Testing is a means of providing feedback to the developer.
We want testing to be fast, we want it to be reliable, and we want it to isolate failures so that we're shortening and amplifying these feedback loops. Depending on the kind of app we're working on, missing a bug may or may not be more important than cycle time.
Yeah, remember that tests are code. That means all the best practices apply to code, they apply to them. Keep them in source control, build them into artifacts, and so on.
There are many different kinds of testing, and the terminology often gets mixed up together. Each kind of testing has many variations and tools you can use to perform it. We'll have separate videos about unit, integration, UI, and security testing that go into more depth and demos for each of them.
But in short, unit testing is performed at build time on a single unit of code and/or artifact without the use of external dependencies or deployment. You unit test a module or a library using something like JUnit, XUnit, RSpec. Those are some of the tools you'd probably use for this.
Integration testing is performed as you bring together pieces of your application and as it needs to use external dependencies like databases to actually do its thing. You integration test a full application or an API or a running server. For this, you might use a RAML test runner or server spec.
End-to-end testing, often implemented as UI testing, is when you test more of your application in a way that the end user actually uses it. This kind of testing might be done with things like Selenium or Protractor.
And of course, security testing looks for flaws in your code and the runtime to prevent compromises and leaking of data in production. Some common tools for this include Find Bugs, Fortify, and Gauntlet.
All right, we won't be able to cover performance testing here, as that's a whole art form unto of itself, like soak tests, spike tests, step tests.
And people like to cite a bunch of other kinds of tests, system tests, acceptance tests, validation tests, that we're lumping into our larger categories for simplicity.
There are some other concepts we need to understand. Here's a quick list of important testing terminology.
Shift left is a term that's become popular for moving testing as much to the beginning, the front in a normal left to right software build pipeline flow diagram, as possible. Developers should be able to run the full app and run every one of these kinds of tests on their desktop before inflicting a change on trunk and the CI server.
Yeah, obviously getting feedback before checking is faster than waiting for a system, or worse, maybe a person, to perform some test minutes, hours, or days later.
Test fixtures are a set of objects used to run a test in a well-known environment. A data set you load into the database before you run the tests is a test fixture. So is a Linux server with a known configuration for your app to operate on if it needs one. Test fixtures are artifacts and should be built and managed like artifacts.
Okay, the system under test, or the SUT, that's QA lingo for the thing that you're testing. So let's say you're testing a Rails app deployed in Heroku, that would be your SUT.
Your cycle time is how long it takes from when someone starts working on an item to its production deployment. This is different from lead time, which is the time from when something's requested all the way to when it's done.
Mocking and stubbing. In unit tests, you write mocks of classes so you can simulate using external libraries instead of really using them. Kind of the classic example here is that you're unit testing code that sends an email. You'd write a mock class that is used instead of the real email sending class.
There are variations on mocking, stubs, dummies, etc. These are subtly different and linked to what kind of test philosophy you're following.
Okay, well that should be enough to get going. In our next video, we'll briefly talk about test philosophy.
Test philosophies, you ask? Indeed. Tools are great, but it's how you use them that will make you succeed.
Here's a quick rundown of some of the approaches to testing people have found helpful.
TDD, or test-driven development, is the practice of writing a failing test first, then writing the code that causes the test to pass, and then refactoring to make it cleaner. This has the benefit of always writing a test and of thinking about what your code should do before just jumping right into it.
All right, BDD, also known as behavior-driven development. It's a refinement of TDD that focuses on simple sentence-driven testing. Tools like Cucumber allow specifying user behavior tests in a simpler way than writing app code, which allows less technical users to participate in test definition and understand the test results.
A TDD, or acceptance test-driven development, extends this to where the project team decides on a set of BDD acceptance tests before development even begins.
Each of these has its pros and cons, but all have proven to have strong advantages in making continuous delivery work.
But what of all this stuff do you need to do? Well, your end goal in a company is to deliver as much value as you can in an efficient as way as possible. This means minimizing cycle time while keeping bugs down to a business acceptable level. Software doesn't have to be perfect, but junky software doesn't get released or purchased.
The important metrics to track are cycle time, velocity, and customer satisfaction. Deep dive QA metrics like test coverage, they're not useful in and of themselves. They're only a means to an end. Focus on how much you're delivering, how you manage velocity, and how many issues customers have from your support tickets or whatever your equivalent is. Those should be your top level drivers.
You maximize these by being strict about always writing a test as part of your code, testing early in the life cycle, and investing appropriately in each level of testing.
Faster cycle time produces better quality, so just adding on as much testing as you can isn't always the answer.
That's right. At Google, their testing experts recommend a 70-20-10% split between unit, integration, and end-to-end testing because the latter are slower and happen later in the process. Also, smaller tests are less complex and unreliable themselves, and more modular tests are more easily maintained in the face of code change.
Okay, let's go from philosophy to practice. In the next video, I'll show you how to write unit tests. With good unit testing practices, a safety net is built up around your code, making changes in the future a breeze. Additionally, they build confidence in the development team to deliver faster. Now, I know not everyone watching is a developer, and even fewer people are Go developers. But the approaches we discuss can be taken for almost any language or framework out there today, whether you are a front-end developer or writing infrastructure. Actually, in the DevOps Foundation's Infrastructure Automation course here in the library, we show you how you can do unit testing on Chef cookbooks. Before we write any tests, let's set up a neat tool for doing visualization and tracking of our tests. For Go, I like to use Go Convey. It's easy to set up and works with the native Go testing package. I'm in the word cloud generator source code, and you can follow along at github.com/wiki/word-cloud-generator. In the make file, I have helpers to install and run Go Convey. I've already installed it, so I'm just going to type in make Go Convey. This pulls up a web browser pointed at http://127.0.0.1 on port 9999. Here I can see what my test coverage is, how my tests are doing, and lots of other goodness. Let's make sure we get notified of any changes. In the menu, I'll choose Notifications, and I'll make sure notifications are turned on for all events. Okay, now we can leave Go Convey running, and it'll watch for changes for our application and rerun all tests automatically, and it'll notify us when something breaks. All right, let's write our unit tests. In my app, there's a package I wrote to take a string and break it up into words, and then score the number of occurrences of each word. I intentionally remove all capitalization and score everything as a lowercase word. I better write a test to make sure that works like I expect. I'll open up Wordy API/API_test.go. In the Go programming language, it's normal to create the test files with the same name as the file you are testing with _test appended to it. The test is completely commented out right now, so let's start by making this test fail by uncommenting the failure message. All right, let's save this, and we should see our error. Yep, there's our error. Looking at Go Convey, I can see my test failure message, and I can see how much code coverage I have. Well, let's go back to the test, and let's make this real. I am uncommenting out the lines in my test file. Before saving this, let's read through it. First, I'll set a string with the word test 7 times in a variety of cases. Then I run it through the parse text function, which returns a JSON object. Next, I have to unmarshal it. And then finally, I check to see if the test sees the lowercase word test 7 times. You may notice some error trapping in the middle. If for some reason my function returns JSON that can't be unmarshaled, then that would fire a failure as well. The basic strategy is that I assert what I expect to happen. If I don't receive that, then I fail and the error message is passed to me along with the state of the object I'm testing. Okay, let's save that. Okay, great. Tests are passing. You probably also noticed that my test coverage jumped as well. Earlier we talked about creating mocks. Mocks are a way to test with fake data for a provider. Let's see this in action. I'll open up main_tests.go. Since the application is a Go app and includes its own web server, it would be a good idea to test that. So I need to mock a server and send a request to that. At the top of this file, this might look familiar. I'll set up my test sentence, but what's unique is that I'm setting up an HTTP request. However, nothing has happened just yet. Next, I'll set up an empty recorder and point to my handler that gets called. This is my mock. And when serve HTTP gets called, the recorder receives the response. After that, it looks pretty much just like our last test. I set up what I expect and evaluate whether I get the right response for that or not. Now, this test has actually been running the whole time and it's been passing, as we've been seeing in GoConvey. But with all this, I hope you see the importance of unit testing. Unit testing gives you the confidence to change the application, and they're often the fastest, cheapest tests around. Well, speaking of fast and cheap, let's talk about one more testing option, linters. Okay, let's take a look at our hook again. I'll open up hooks/git-pre-commit.hook. Before code can get committed, go format and go vet run, a code formatter and linter respectively. This maintains code standards for all developers on the project. I added a helper in our makefile to run golint. Let's run makelint now. This runs golint, goformat, and govet. Now it found a few problems, mostly exported variables and functions that should be commented. Nothing serious, but it is a code quality issue. Most languages and frameworks have linters and formatters available. For example, if you're doing infrastructure coding with Chef, you can use Rubocop and FoodCritic. Whatever your language is, I highly recommend to start using these tools in your delivery pipeline today.
Once you've built and tested an artifact, the next thing you need is self-service deployment of that artifact to a working system so that you can run more tests. Once you have a self-service deployment, then making it continuous, in other words, automatically promoted, is purely a policy decision to hook one stage to another instead of pushing a button. You might deploy locally on a build server first to run integration tests, then to a testing environment to run more integration and acceptance tests, and then deploy to a production environment. The trick to good deployment is to always make sure things are the same. Deploy the same artifact you built and tested, don't build it again or use a different artifact. Deploy to each environment using the same deployment code and process. Using one mechanism for test and another for production guarantees you'll have production deployment issues. Deploy to similar environments. They don't have to be identical in terms of system resources, but they should be identical in all functional ways. You can bring your app up on the build server or similar for a first run of the integration tests, but your test results aren't good enough for release unless you've tested on the target platform. At work, we have one build that gets targeted to a lot of platforms. We make AWS AMIs, VMware images, Hyper-V and Azure images, and so on. We bring the software up on our build server to run the integration tests. But when that passes, we deploy it to all those target platforms and retest there. And finally, run smoke tests that verify that the application is up and working at the end of every deployment, whether internal or production. Deployments should always self-validate their state at the end. A product I work on uses the Robot framework for its UI acceptance tests. I encouraged the developers to tag tests with the tag smoke if they were safe to run in production and wouldn't mess up any data. So we use the exact same test runner and test suites for each layer of deployment and just cut out tests that aren't appropriate for that layer. There's a couple other tricks to continuous deployment. The first is to deploy small batches, of course, the same as with continuous integration. Smaller batches mean less change. And Gene Kim's research for his book Visible Ops determined that 80% of production outages were caused by someone making a change. If you deployed a very small set of changes, there's less to go wrong, less to troubleshoot when it does go wrong, and a much shorter path to fix. Also, keep your changes loosely coupled to each other as much as possible. Requiring two changes to go out at the same time is an anti-pattern. The developer should spend the time to make the code do the right thing when faced with either path. Basic API versioning, data schema versioning, etc. enable code to smoothly handle a set of database data migrations or the like. Remember, you're releasing small batches quickly, so on day 1, you can add a new column to the database. On day 2, have the code start to populate it. On day 3, run a full data migration for historical data. And on day 4, start serving it back out from the new column. Releasing all that at once can leave you in an intractable position if any one step goes bad. Also, deployment and release don't have to be the same thing. For example, you can do what's called a blue-green deployment by maintaining 2 sets of production servers, deploying to one set while it's out of service, testing it, and then swapping it in with the old ones ready to go back in at a moment's notice. Or you can use feature flags or toggles, which allow you to turn features or versions of features on or off, either totally or on a per customer or group basis. So you can deploy that new sidebar full of enriched data, turn it on, and then turn it off again if there's a problem. Web companies like Twitter and Facebook make extensive use of this scheme, turning off non-critical screen widgets if they have problems or even if they're having overall performance issues. This extends the branching by abstraction pattern into the operational environment. There are a lot of deployment pattern variants you can use. Canary deployments, where you bring one newly deployed server up into traffic to see how it does, like the proverbial canary in the coal mine. You can build on more detailed control to show new code to a ramping up percentage of your users if you want. As for deployment tools, I wish I had better news for you. Since how you deploy has a lot to do with what you choose as an artifact and your type of system, there's not a set of clear leading options here. You have your basic SSH tunneling pulled directly out of your source control tools like Capistrano. This is old but still used a lot, even though exposing your version control system to your production environment is a little questionable. If you're packaging your apps as OS packages, using a CM tool like Chef or Puppet is popular. But if you want more control, you might use an orchestration system like Rundeck or Ansible. Or you can just build deployment into your build system. Or if you're using Docker or serverless technologies, there are ways to do it for those that are totally different. And of course, there's a bunch of commercial options. None of these are mutually exclusive. You might use a couple in combination. And many folks still roll their own deployment code. James wrote a custom in-house deployment dashboard for Signal Sciences, similar to Etsy's open source Deployinator dashboard. People do this a lot because most of the options I mentioned have terrible visibility and dashboarding around releases. In my shop, I use our build system, Bamboo, to perform deployments for one of our products. Having the deployments in the same UI as the builds is compelling, and my deployments end up just exercising Amazon Cloud APIs, so it fits our use case. But for our more complicated product that has on-prem customers needing to consume updates, we build the Debians, push those to an update server, and then initiate Puppet-based installation using a Rundeck orchestration server on our systems. Use a deployment system that is as simple and reliable as possible, and only add stages and complexity when the requirements necessitate it. Next up, I'll deploy our sample app using Chef and show you how that works. All right, let's add some deployment to our build pipeline. Deployment's probably the most variable part of the build pipeline, but we're going to show a deploy using Chef just to have something to hang our hat on. So here I've set up a test fixture Docker container. We talked about test fixtures earlier in the course. I'm showing you the Docker file here. I've already installed SSH, the standalone Chef client, and the Chef development kit, in the Docker file. Usually you wouldn't run SSH in a Docker container, but we're specifically using it to emulate a remote system here, so it's kosher. You could of course do this with virtual machines or Amazon instances or real remote machines, but boy, these little containers are fast, configurable, and perfect for our demo environment. We'll go look at our Docker Compose file that we're using to control all this. Go down and look at the test fixture section. So as you can see here, we're building our test fixture container. We're live mounting a Chef repo directory that's already been set up with a standard Chef repository skeleton. And it's running on port 8888 for our application and port 2222 for SSH. Let's go take a look at that Chef repo real quick. All right, so this is a standard kind of Chef cookbook repository sort of framework. All I've added to get us going is a freshly generated cookbook using the command chef generate cookbook word cloud generator. And you can see that it has made a default cookbook here in word cloud generator. And then all I've done is edit the metadata.rb file to, put my brand on it. Most of the work, however, is under recipes in the default.rb. All right, so let's take a look at our recipe. In here, I'm doing a couple things. The first thing is I'm creating an optcd class directory to hold our application. The second thing I'm doing is declaring a remote file and downloading our latest version of the word cloud generator from Nexus, the exact same way that we did in the Nexus video. And then here at the end, I'm unzipping it and then running it as a service using the Poise service library. And after I did that, I made this little word cloud generator JSON template. So what this is going to do is specify what version we want to install. So what I've done is I've actually created it as a template that our build is parsing and replacing this one.development with whatever the latest version of the build is. And then we'll pass that into Chef to say install the newest version. Okay, so let's SSH into our container. It's at port 2222. If you haven't already started all of the components, you would do it with the docker compose up-d command that we've covered in the previous sections. I just already have it still running. Of course, the password to root on this is the Agile admin. So we're going to check that the Chef client is installed and running by running chef solo-v. Sure enough, we got Chef version 12 up and going. Really, we should write a server spec test to do this, but I'm doing it manually for the sake of the demo. So now let's look into Chef repo, which is mounted into the container. It contains all the files that we just saw out on the host file system. So there it is with all the cookbooks. And now let's look at /opt. And you can see that since this is already run once, we have our optcd class directory in there with some version of our word cloud generator. So to prove to ourselves this is going to work, we are going to kill the running word cloud generator by finding and killing its PID. And then we'll go ahead and just remove all of optcd class. All right, so we should all be super clean. So we're going to go over into Chef repo. And then we're going to run chef solo, which is the chef runner. We're going to give it its little solo.rb config file which just tells it where the cookbooks are and where its cache is. And then it's going to take our JSON file that has the specific version that we want to deploy, in this case 1.7. All right, bam, it pulled down the file, it unzipped it, and it ran it as a service. So we should be able to see it running in the process list. Indeed it is. Then we'll go out to our browser and verify that it's working. Here we are. Localhost, port 8088. And there we have a word cloud. I've also added a version endpoint to this app, so you can hit it and see what version you're running. That's a little pro tip that helps you trace back a running application to an artifact and then back through the build cycle. So how you run the deploy remotely. Yeah, we ran it via SSH. You can run it via the Chef program knife or via any orchestration tool is flexible, and you should customize it to your environment. In the DevOps Fundamentals Infrastructure Automation course here in the library, we go over orchestration tooling and approaches. You can even trigger deployments straight out of your build tool if you want. And as a matter of fact, we've done that with our word cloud generator build. If we go in and configure, I'll show you the build stage. So remember our actual build stage, our upload to Nexus stage, and then I added a build stage, which simply parses in that build number into the word cloud generator JSON template, and then SSH's, it executes this via SSH on the test fixture container, the same Chef Solo command that we executed by hand. It's port 22 here because that's inside the Docker network, where we're mapping it to port 2222 outside, available from the host, in case you're finding that confusing. And then, of course, this is the time for more tests. Chef can run tests to make sure that the expected files and processes are in place. And next, we'll run our integration and UI test suites on this deployment to make sure that it's healthy. Well, that's a super basic deployment strategy that shows how you can have a decoupled deployment that consumes your artifact from your artifact repository with no necessary dependency on your version control system or build system. I also wanted to show here the importance of passing your artifact version through the delivery pipeline. It can sometimes be tempting just to have your deploy systems, run with pull latest, but asserting the version all the way through is key to a CD pipeline. All right, now that we have a deployed application, let's talk integration testing. While unit tests just operate on the application code, integration testing is any kind of testing you do on the assembled program, or that truly exercises its external dependencies, database, network, file system, or the like. Depending on the kind of application, this could just be exercising it at the command line or exercising its API or other interfaces. Often you'll have layers of integration testing as you assemble more parts together. One common option is to just write integration tests in code, maybe using a unit testing framework like JUnit. But you need to be careful not to mix up your unit tests with your integration tests. Unit tests should run quickly, not just in builds, but all the time from the developer's IDE. But having said that, it's in your best interest for developers to be able to run integration tests on their desktop. The more testing an individual developer is empowered to do before checking in their code, the smoother the pipeline runs. Let's look at our sample app, the word cloud generator. It has a simple REST API. Here, we're going to post some text into it and get the JSON response back. I'm just using curl and passing a JSON payload to our word cloud generator app running on port 8888. And it gives me JSON back with the JSON representation of the word cloud. So obviously we could just write some code to make a call like this and validate the response, but we're going to look at a more interesting option. What if we wrote a definition of our API, which we could then use to run tests, generate documentation, and set up monitoring? Well, behold, such magical things exist. There are several, in fact, including Swagger and RAML, the REST API markup language. Here you can see an example RAML spec. You can define all the different aspects of your API. By defining your API contract, other teams can use your API right, can mock it, you can auto-generate documentation and tests. So let's look at a RAML spec for our app. We have a RAML files directory here in our example files. And we'll look at the wordcloud.raml. So here you can see I'm defining that /API endpoint that we called. It takes a post call of a payload that just has a text string. As you can see, I've actually put an example here in RAML using the same example we were using from the command line. Then down here, this declares the sort of response you should get back. There should be a response code of 200, and this is the JSON schema of the payload that you should get. And again, here's an example. And then, of course, our version endpoint has its own little definition here, saying how you should call it, in this case a get, and what you should get back. So let's do this for our app. So we've generated its RAML, and I just did that by hand from knowing how the application was written. Anyway, this wordcloud.raml file is included in our example files. So now that we have a RAML spec for our app, how can we use that to test it? We're going to use a test runner called Abao. Abao takes your RAML definition and examples, and it'll actually run a validation against your API. I've just made a small Docker container with Abao in it. Here's the Docker file. This is just a stock Node.js container. I'm installing Abao and Chai in it. I am mounting the RAML files directory I have here as a volume and declaring the entry point just to be the command line Abao. To build it, we Docker build what we want to call it. All right. And that didn't take long because it's already built and up to date on my system. So now we're going to run it with our RAML file. So we're going to say Docker run. We're going to mount as a volume our current directory to /raml inside the container. We're going to use the host network so that the runner can get to the local host. Going to clean it up when it's done. Going to pass wordcloud.raml as an argument. And we're going to run it on localhost port 8888, where we've got our word cloud generator running. So we run it. It went, it validated the API endpoint, and it validated the version endpoint, live against the app from that RAML definition. Again, I want to stress that RAML definition isn't just like an Abao config file. That's a standard format that you would just use to define your APIs. And then you have tooling like this that is smart and understands how to consume that. For example, I know if you're using Swagger, there's a monitoring service provider called RunScope where you can load that in and start monitoring based on having had a actual API definition. So this just checked the response code and the body schema, but let's say we want to inspect it a little bit more deeply. So Abao supports what we call a hook file. And here we have one called wordcloudhook.js. Okay. This is a standard format. In fact, most of this Abao will just generate for you. And then you come down here and you fill in exactly what you want to test, either in the request or the response of the body. So for example, here, I want to make sure that it's actually finding 6 dings. So when you just run Abao using the RAML spec, it's running it and it's making sure that it got well-formed JSON back, but it's not able to understand, what exactly you should be expecting from a certain input. I'm also checking that the actual version : string appears in the version endpoints response. And that's just using normal JavaScript. I don't even know JavaScript, but given the examples here, it was easy enough to make some more. So what we're going to do is we're going to run that same command, except we're going to add hook files, wordcloudhook.js. And this time it's going to run, and I've got it also printing out the requests and the response so that I can visually validate it. But sure enough, it went through and it said, hey, everything came out correctly. And just to make myself happy, I can look here and see the requests and responses and see that I'm getting what it is I expected to get. And both tests pass. So, of course, the next step is to get this working from within our build. Here we've gone back to our word cloud generator build in Jenkins. We're going to configure it and go down and look at the build stage that I've inserted to run the about container. So just like we ran it from the command line, if it fails, if both of those tests won't pass, then this stage will throw an error and the build will fail. But if they all pass, then it'll return a 0 and this build stage will succeed. So you can layer in as many kind of test layers as you want, even just custom by hand ones, as long as they conform to the usual kind of Unixy convention that return code of 0 is happy and return code of non-zero means unhappy. So you can also break integration tests out into a build of their own. Depending on how long your integration tests run, you might run all of them on every build like this, especially if you're continuously deploying, or you might have another build on a cadence. You might run certain of your integration tests inside the primary build, and then you may have extended integration tests that do much more sophisticated things, perhaps against when you deploy to other platforms. Let's say I'm generating in the build here actually a Mac, a Windows, and a Linux word cloud generator executable. If I wanted to deploy those to all three of those different platforms and then go run tests, I might decide that that's too long to fit into the one primary build in the interests of fast feedback to the developers, and I could break that out to another build. Of course, if you're not continuously deploying and you have gated releases, you can figure out the timing of the different layers of tests in a way that makes sense for you. Just one final note, we are running a Docker container actually from within a Docker container here. I didn't want to confuse anybody by talking about it earlier, but if you're wondering how the heck that was done, it's still just a simple Docker file, but in the Docker Compose, we're doing a little trick of mounting the var run docker.sock file. And in the Jenkins Docker file, I've made a couple other little ownership changes that allow you to mount that, and then even from inside a Docker container, it can exercise Docker at the host level and run other containers. So in case you were wondering about that. All right, next up, we will show how to test our app end-to-end from the UI level. Well, we've tested our API, so now let's do some end-to-end testing using our UI. UI testing has its advantages and disadvantages. On the one hand, it totally simulates the user experience on a UI application. Levels of testing below it just aren't complete. But on the other hand, it's slow and usually pretty touchy. UI tests require a lot of maintenance in the face of app changes. End-to-end testing is about making sure the application flow works correctly after it's integrated with everything. You can use it to perform regression testing, ensuring the app still works the way it should after a change. And acceptance testing, validating that new functionality works the way it's supposed to from an end-user perspective. There are a bunch of UI testing frameworks, but one of the most popular for web UIs is called Selenium WebDriver. What you do with Selenium is you use the library to drive a browser, but you end up having to write code to actually exercise it. But there's a tool that I like that abstracts a lot of that work out. It's called Robot Framework. It's a test runner that uses a BDD type language, Gherkin, the same language that the Ruby BDD tool Cucumber supports. It has a bunch of plugins, but one of the most interesting is the Selenium 2 library plugin that lets you drive a browser from Robot. It also supports the page object pattern, which is important for maintainability. What this means is that you define the specific HTML pages and elements of your application in an encapsulated resource model, and then all of your test code just refers to that. So if you change, for example, the login button, instead of having to go find the specific way that you've referred to that button in 100 different tests, there's one canonical place to go change it. So let's test our app in Robot Framework. We're going to do something a little different this time. We can run robot tests headless in a browser, so we could just wrap that up in a Docker container and put it into our pipeline. But then you don't get to see what the browser's doing. So for purposes of this demo, let's look at a robot test definition and run it locally. So as you might expect, there is a robot tests directory in the example files. And in here, the first thing we're going to do is actually activate our Python virtual environment that already has Robot Framework and the Selenium 2 library installed. You would instantiate it by saying source venv bin activate. That puts you in your own Python virtual environment that's separate from whatever you may have installed on your system. If this doesn't work for you, there are instructions in the README on how to regenerate the virtual environment on your system with the correct libraries. So once we're in here, we should be able to run robot just by saying robot, and sure enough, it's there. And it says, hey, you should probably tell me a little bit more about what you want me to do. So let's look at our test files. I've made a resources.robot file that is that resource definition of our actual pages. So the first thing to understand is look at how understandable this is. It's not like normal source code. This is something you can let product managers or other semi-technical folks write tests in. So I've defined our kind of top level URLs and such. And then I've defined a number of keywords. There's one that opens the browser to the home page, one that validates the home page should be open and it should have a correct title. And I've made utility functions like input word cloud text. Again, this is in the resources. Now every single test that gets written can just say input word cloud text and give an argument instead of having to understand the DOM descriptor or whatever of that actual text box. So we're going to also look at the test file, which is wordcloud.robot. So this word cloud test is going to open the browser to the home page, input text, submit it, verify that the page is open, look for the word ding, and close the browser. Pretty simple. I also have a test for our version endpoint that's simpler. It's going to hit it, look for the word version, and close the browser again. All right, so now let's run them. Robot has a zillion command line options, but the only mandatory one is the directory to find its tests in. So we're going to run robot with the current directory, and it's going to grab all the .robot files in there and run them. And then what you're going to see is browser windows are actually going to pop up, run the test, and close again. That's our version test running. And now our word cloud test. You notice how Chrome is warning you that you're being driven by automation. And the test is over. So back in our terminal window, you can see that those tests passed, and it generated output, a log, and a report. Let's go take a look at the detailed test report. All right, we'll open the file. It's saving them down into our robot tests directory. So you get a lovely test report. It's all green because everything was happy. And you can drill down into specific tests. And once you get into the output, you can actually drill pretty far down into seeing exactly what happened. If you're interested in kind of exactly how long the open browser took and what exactly it did, you can delve down into it. When there are errors, of course, this is much more interesting to come and dig into to find out exactly why your UI test may have failed. So you can stick this into a Docker container using XVFB to run headless and add it to your build. We do this at my place of work where I've written a wrapper to handle parallel robot runs, run cross-browser tests using Sauce Labs' service, do system under test setup and tear down, and more. One last brain teaser. Do you remember how on the version endpoint I just checked for the string version? Because how would the tests know what the current version is, right? Well, all these tools and tests should also have a build and generate their own artifacts. If these tests were in the app source control repo and they got the real version number injected into them, just like the application does, then you'd have a test artifact version linked to the app that can run and even make sure it's running against the version of the app it was coded for. All right, I know that was a whirlwind tour of the different types of testing. Our goal here isn't to teach you any of these tools in depth, but just to introduce you to the concepts of the different kinds of testing and show you a real-world example of how each might be performed.
Let's talk about the really fun part of continuous delivery, security testing. I love this topic. Now, there are a bunch of ways we can go with this, so let's start by discussing how security fits into the overall picture. There are two main categories of security testing that work well for a delivery pipeline. The security industry is full of fun acronyms like SAST and DAST to describe this concept, and even runtime variations like RASP and IAST, but let's just break this down into two categories, static and dynamic. We're going to take a look at a dynamic security approach and then a static testing approach. Dynamic security testing differs from other testing in that you run it against a deployed and running application. Let's look at some pros and cons here. In dynamic testing, you don't really assert anything other than statements like, this form should not contain cross-site scripting, or Nmap should find no extra open ports. Because you test actual payloads and actual security attack tools, you are asserting not what you expect, as you do in unit testing, but you assert that the tool itself shouldn't find any problems. Well, this is actually pretty cool. Dynamic testing is a good collaboration opportunity between groups of developers, security engineers, and operations. It gets these differing groups together, sharing testing goals and outcomes. There are some gotchas, though. Dynamic testing requires the system under test to be running, and sometimes they can be slow, so you might end up running them in parallel depending on your constraints. Well, let's take a look at a dynamic tool and run it. I'm one of the core developers on Gauntlet, an open source tool for dynamic security testing. For this course, I want to discuss how you can integrate these types of tests into your delivery pipeline. Gauntlet helps automate any attack tooling to run against your infrastructure, ideally as part of your CI pipeline. It uses a plain English style approach, and all the tests follow a given, when, then convention. In this example, you can see the three commands in action. First, we say what we are testing. Next, the given step is a setup of a target and a tool. Next, the when step is the actual execution of the attack. Last, the then step is asserting the outcome that we want. In this case, we're saying 0 issues were detected. If any of the steps fail along the way, the attack test exits and the build fails accordingly. There's plenty of getting started information on gauntlet.org. For this demo, we'll be using Gauntlet running in a Docker container instead of installing Ruby and the Gauntlet gem on our development machine. Running in a container makes this well suited to inject into a delivery pipeline, as it isolates all necessary runtime dependencies. Let's head over to github.com/gauntlet/gauntlet-docker. This gives you everything you need to get started and includes the attack tool Arachne. I'm heading over to the command line, and I'll clone the repo by typing git clone git at github.com:gauntlet/gauntlet-docker. Next, I'm moving into that directory. Let me clear my screen. and I'm going to type in make build. Make build sets up the containerized version of Gauntlet. This takes a minute, so we're going to fast forward through this. Okay, great, all done. Now, I like to add containerized applications to my path so I can treat them like any other app. I have a helper here to do this, also in my make file. I'm running make install. Okay, everything should be set. I'm going to clear my screen here, and then let's run gauntlet-docker --help to make sure everything works. All right, that's the help screen for Docker, so commands are getting passed in. It all looks good. Okay, I'm clearing my screen and heading over to our word cloud generator app and looking in the Gauntlet folder. I'll open up xss.attack with Vim. In this attack file, we're testing for cross-site scripting by harnessing an attack tool, in this case Arachne. All right, notice that I'm running here against word cloud on port 8888. I set this name in the etc host file. I did this due to some limitations of Arachne and how it runs against localhost. Here in the xss.attack file, we can still see the given, when, then structure. Given Arachne is installed, which is installed in the container. When I launch an Arachne attack with, and it has Arachne with a bunch of commands behind it. Then the output should contain 0 issues were detected. That means we didn't find any cross-site scripting inside of word cloud. All right, before we run Gauntlet, this assumes that you have the word cloud generator running on port 8888. If you haven't been following along with the class, you might want to back up and get that launched now. Okay, I'm going to clear my screen and let's run it. I'll just type gauntlet docker since it's loaded in our path. Gauntlet looks across the entire subdirectory for any attack files. That's any file that ends in .attack. It found xss.attack and it executes each step in order. You might notice that we limit Arachne to run only the XSS attacks, rather than running all of the attacks that it contains. This is key since security tools often run spiders and crawling steps that take a long time. For your app, you know right where the login page is or the search page is. Gauntlet helps you isolate these to test in your app. We can attach this to our build pipeline, CI system, or wherever we put our other test runners. For more info on this, check out gauntlet.org. Now let's turn our attention to static testing. Commercial options include Fortify and Veracode, but there are also some open source options like Brakeman. These do full static analysis of your code for vulnerabilities. There's also a raft of static scanners that check to see if you're using vulnerable libraries. These are commercially available from Sonatype or Black Duck, but open source options abound with choices like Bundler Audit or Retire.js. Let's take a look at Retire.js, which looks at all the versions of JavaScript libraries that you're using and checks for vulnerabilities. All right, I'll clear my screen here and I'll install Retire.js with npm. I'm typing npm install -g retire. All right, looks good. Now I need to change over to the static directory. I'm going up a directory and over to static. I'm going to add a known vulnerable JavaScript library to my project and see if we can detect it. I didn't ship this with the code because I didn't want to include a bad version knowingly. I'm going to run wget to download this bad version of jQuery. Okay, I got it. Let me clear my screen here, and now I'm going to run retire-j to check. All right, it found it and complained about us trying to use a known vulnerable library. That's pretty cool. This is very useful to make sure the team hasn't accidentally added in vulnerable libraries. For whatever language or framework you're using, there are options to test for this. This wraps up security testing, and I hope you have some new ideas to try out and that you had half as much fun as I did.
All right, now you've seen a sample pipeline, and we've talked about best practices. Keep everything in version control, use artifacts, minimize branching, commit frequently, shift testing left, and so on.
But there's some best practices for your overall pipeline you should keep in mind.
The key is that each developer has to understand that the successful build and deployment of their check-ins is their responsibility. Not a build engineer, not a QA engineer, not an ops engineer, theirs.
Yeah, even if other people are involved in that chain. Your change is not done until it's successfully deployed in production.
Small changes and build quality in. This is the lean mantra that should always guide your decisions around your pipeline.
That's right. You know, the more changes you make at once and the longer you delay testing, the more bugs you have, and the harder it is to find them and fix them.
That's right. Let's talk broken builds.
While broken builds aren't bad per se, you don't want them to linger because it blocks the team and it tempts people to pile on more changes that don't get tested.
Other engineers shouldn't check in or merge to master when the build's broken. If they're in a hurry, they should help fix the problem. You should always watch to make sure your build succeeds and never leave a broken build behind.
When your commit breaks the build pipeline should stop and you should immediately fix the problem, usually by reverting to a prior version and working on the fix at your leisure. Attempts to push forward and fix the build in place shouldn't be allowed to really take too much time.
Of course, good testing discipline facilitates success. High quality testing, automated testing, is crucial to continuous delivery.
All right, developers should always run the tests locally before check-in, or have a branch that builds and runs them before merging into master.
And don't allow flaky tests, and don't just comment them out or ignore them. This degrades confidence in your pipeline. Tests are code. Log a bug and fix them stat. Don't say you don't have time. What you don't have time for is delivering big bags of buggy code like you used to.
Yeah, keeping the build clean and test passing that's your first priority, and you'll be able to rely on your build in that case.
I'm not going to say that you should have no manual QA, but that QA should be focused on very high-value activity and finding things that are impossible to find with automation, not doing work a computer should be doing.
Yeah, use QA as expert consultants on how to construct good tests to build maintainable UI tests, valid performance tests, and doing resilience testing.
The same basic concepts apply to the deployment stage. Automate your deployments and use that automation at every phase, from on the dev desktop to CI deploys to production deploys.
Every piece of your environment is code that should be continuously built and validated. And when your environment creation is automated, then each one is nearly identical. And one of the largest sources of surprise bugs is eliminated.
Now some advanced topics. Keep the build and deploy fast. When anything starts taking more than a couple minutes, you should start looking into why. Make component builds and test runs parallel, tune timeouts, and build system parameters.
Remember the 70% unit testing, 20% integration testing, and 10% end-to-end testing rule from our testing philosophy video. The slower the build, test, and deploy is, not only does it affect your cycle time, but it becomes hard for the developers to pay proper attention to the build.
Dan Bodar did a great presentation back in 2012 called Crazy Fast Build Times, or When 10 Seconds Starts to Make You Nervous, where he presents a lot of ideas to really dig deep into removing time waste from a build cycle. The more you stick to these practices, the better your continuous delivery will work. I work on one system that's pure continuous delivery. Every piece of infrastructure build, all the tests, all the app code, even the monitoring configuration. It's all in source control, it has a build, it becomes an artifact, it's deployed across our environments, and it's tested at multiple points. Developers can check in code, and minutes later it's in production. It's become routine. All it takes is the discipline to say we don't do things manually or without tests.
All right, that all sounds great. In our next video, we'll talk about the challenges you're going to face doing continuous delivery in the real world. Theory is all well and good, but the real world is full of pointy-haired bosses and other perils.
There are also technical hurdles that come up, like long-running tests or complicated build matrices.
My best advice is to create a desire in your team for doing continuous delivery. There's a famous quote that says, if you want to teach people to build a ship, don't overload them with a bunch of tasks, but instead teach them to desire the endless sea. This is our goal in real life. Have our team imagine a pipeline where they can go from code commit to deployed in just a matter of minutes. And they're going to see how much that can change their lives for the better.
The real world isn't perfect, so there's not a single perfect continuous delivery pipeline. It's more of a changing process that looks different based on your specific needs.
The most important thing to watch is total cycle time. We sometimes have a myopic focus for optimizing one part of the build, but it's the overall rate of flow that matters.
You'll need to balance the benefits of fast feedback with the speed of a single build. If you run the integration tests on the dev desktop, on their branch before it's merged to master on the build server, and then again when it's been deployed to a real CI environment, that's 4 runs of the same test. Is that good or bad?
Yeah, Ernest, that's right. It kind of depends on your situation. If you're getting a lot of bugs in your builds and a lot of builds break, well, then stopping the build earlier and getting faster feedbacks to the developer, that results in the lowest time from the start of work to actually shipping your code.
But if most builds are successful, then running the tests multiple times prior to the true validation run adds to build time and increases your overall cycle time.
Yet you'll constantly need to experiment with the right mix that gives you the best overall cycle time. At my office, our total cycle time is around 5 minutes, with about 4 minutes for the build and all the testing with that, and then 45 seconds for deploys. Now, that may sound like crazy to you, and when you hear us talk about total cycle time of just a few minutes, that may seem unobtainable in your current environment. You'd probably just like to get it down to weeks or just a single week.
Fear not. When I started at Bazaar Voice, we worked to get a product from a 6-week release cycle down to 1 week. It took a while to do it, and that's where we ended up stopping. We had continuous integration for the builds, but on the business side, support, marketing, and product, 1 week deployment cycle was as fast as they could handle. And that's okay. You don't have to go all the way down the continuous deployment rabbit hole.
Well, we've noticed that there are 3 areas where continuous delivery efforts often fall short.
The first problem we've seen is that builds are not reliable. This is usually due to tests being flaky and causing builds to fail sporadically.
One place we worked, the builds had some 4,000 tests, and any number of them would fail, and you'd have to consult a build engineer to find out if any of the really important tests were the ones that failed. I mean, that's a build that you cannot trust.
Builds should ideally run in less than 5 minutes and shouldn't sporadically fail.
If you start to notice more bugs, more performance problems, or other quality problems, it's time to pump the brakes and evaluate your testing strategies.
Testing is at the heart of continuous delivery, and you can't test just one part.
It's important to evaluate testing across the total system.
The last problem area that we've run into is long deploys. Sure, the build takes a few minutes, but to deploy to all the servers can take an hour or more.
Yeah, this has a psychological effect where people begin to actually deploy less frequently, and then you run back into the old pattern of infrequent delivery of a larger and larger number of changes.
We suggest asking questions as a team on how to unite configuration management and deployment to make sure your deploy times stay low.
There are going to be trade-offs that we just can't predict or enumerate here. Use the principles behind continuous deployment to figure out what's the best thing to do when they arise.
And finally, just do it. Most organizations fail at continuous integration or deployment strictly for lack of trying. It's not technical hurdles, it's personal discipline.
In the end, most of the work is just taking responsibility for your build and making sure there's a test with each check-in.
If you do it, you'll be successful. If you don't, you won't. All you need, as we say down in Texas, is a little bit of gumption.
Some gumption. Well, despite the challenges, I can say positively that when you get continuous delivery working in your organization, it changes everyone's life for the better.
No uncertain deploy windows for operations.
Yeah, and you get to see your code in customers' hands before going home each day. I mean, that's incredibly rewarding in itself.
I guess we could sum this up as, even though it's hard, CD in the real world is worth it.
And that's our course on continuous delivery.
Together, we defined continuous delivery, identified key practices, and built a working delivery pipeline for a Go application.
Yeah, along the way, we gave pointers and tips for each stage of your pipeline. However, at this point, you may be wondering, where do I go from here?
Well, if you haven't watched some of the other DevOps courses, we recommend going to our DevOps Fundamentals course.
In that course, Ernest and I cover the whole span of DevOps at a high level and explain the main practice areas, one of which is continuous delivery.
Going back to that course to make sure you're aligned with where delivery pipelines fit into the larger scope of DevOps would be a good step.
Yeah, and if you're a sysadmin or you're in operations, I would really recommend watching DevOps Fundamentals Infrastructure Automation, also available here in the library. That course is designed to fit with this one, and if you're delivering infrastructure as code, that one's for you.
Of course, we'd be remiss if we didn't mention the excellent book on continuous delivery by Jez Humble and David Farley. Most of what we know about CD, we learned from that book.
When I started working on building pipelines, I read that book, and it really served as a roadmap for me.
I can't say enough good things about that book. It's the standard reference on continuous integration and deployment, and it covers the topic in much more detail than we can do here.
Also, the Google testing blog at testing.googleblog.com is an excellent source of best practices.
Besides mastering these techniques, they've recast the role of QA as being focused on engineering productivity and have a lot of great ideas that they've proven out in one of the world's largest development shops.
All right, well, that wraps it up. Find us on theagileadmin.com or on Twitter.
Thanks for watching, and we hope to see you soon.